allow me introduce you to real writing chemical compounds, as we know. Now, when you're writing chemical compounds, you must know the correct formula, the correct symbol. These are the steps. Correct symbol of the element. Of the element. Correct symbol of the element. That is one. Secondly, you must know the valency. What did we say valence is? What did we say the valence is?
Valence is a combining power of an element.
Thank you very much. Where have the rest gone? They have disappeared.
Yes.
They will find us when we are far and well, they have decided to take off. Okay, Mutumba has come. So this is a combining power of an element. Combining power of an element. Of an element. Good. Now these are the steps for writing a compound. Steps for compound formation. Good. So this is the first one. This is the second one. Secondly, this is the third one. Now the third one is you write the two in a row and then you must show power exchange. Power exchange. I'm going to show you what power exchange means. Is if they want you to write an example, let's go back to this table up. They have told us to write a compound called ammonium carbonate. Ammonium carbonate. Now, the first step for you to write is to write the correct symbol of the element, of the elements present. Correct symbol of the elements or radicals present. Stroke here, elements, stroke radicals present. Present. Which elements or radicals are present? We have ammonium and the carbonate. Isn't it? Now, ammonium is written as NH4. The whole of this, what is their valency? What is their valency?
1.
1. So it is 1. Either you put 1 or plus 1. It is upon you. For me, I'm used to 1. So we can also put ammonium here with a 1 on top. 2. We have a carbonate. You run straight to where a carbonate is. That a carbonate is CO2, CO3. What is the valency? What is the valency? It is under valence what? 2. Okay? So since it is a negative ion, we shall say it is magnesium carbonate 2 minus. That is what is there. Or someone can just write CO3 and then puts a 2 up. That is correct symbol of the element is here. NH4 is the symbol of ammonium. Then carbonate is CO3. Then the valency or the combining power, you put it on top here. This is our valency. Valency. Valence is there. No valence. Like that. Then, now you must show power exchange, because if a compound is to be formed from these elements, they must exchange their powers to show that they have formed a new compound. This one, the power of this will come straight to this one. Then the power of this comes straight to that one. Okay?
Yes.
So if they exchange the powers, ammonium takes the 2, NH4, it takes the 2 of the carbonate. Huh? Then the one of this is taken by the carbonate, which is CO3. It just remains like that. So the compound becomes NH4, then there is a 2, then CO3. This is a compound we call ammonium. Ammonium what?
Carbonate.
Carbonate. So now let me take you through an example that requires you to reduce on the powers. Okay. An example, if they tell you to write magnesium sulfate, magnesium sulfate. What are the whatever's concerned, the elements or the radicals present? We have magnesium and what?
Sulfate.
Huh?
Sulfate.
Magnesium and a sulfate, isn't it? Yes?
Yes.
So
Yes.
here we shall have magnesium. What is the symbol of magnesium? Write the correct symbol of magnesium.
G.
Mg.
Mg. Mg. Then a sulfate. Sulfate. Somebody gets it from here. Read from here. Read from here.
Yes.
A sulfate ion.
S.
SO what? 4, isn't it? Okay.
Yes.
Then assign
Yes.
each of these the correct power. What is the power of magnesium? The valence of magnesium? Go to the table and check. Where is magnesium? You copied it. It is under valence 2, isn't it?
Yes. Yes.
So it becomes 2 what?
2.
2 plus, isn't it?
Positive.
Then the sulfate. Sulfate is also under valence 2. So it becomes 2 minus, isn't it? Now, since this power and these ones are the same, they reduce each other, okay? This one reduces this by 2, divide by 2, you get 1, by 2, you get 1. So the formula of magnesium sulfate becomes MgSO4. Okay? Is that clear?
Yes. Yes.
So if you have now seen why powers don't change. Now these ones, the powers do not cross because this is 2, this is 1. There is no way you can cross. But these ones, the powers are the same. Now imagine something had the valence 4, and then this one had the 2. So they reduce powers. One becomes 2, another one becomes 1. Okay? Please. Who is shouting on the ground? Someone is making noise. Okay. So we can now continue. We can now continue. Now, if they want aluminium sulfate. Can somebody write for me aluminium sulfate? I'm waiting for aluminium sulfate. Come up with the answer in 2 minutes. Aluminium sulfate. Ruth.
Teacher, can I try?
Yes.
AL
Al. Mhm.
SO and 4.
SO4.
Hmm.
That is the hollow compound. Did you follow our steps? The first step is to write the correct symbol of the element. The second one is to write the valence on top. Then if they are not the same or if they are not reducible, you write the power exchange. Did you do that? Yes?
Right to minus.
First write the hollow compound together. Go to the table, check where aluminium falls, which valence, write the valence of aluminium on top. Go to the sulfate, look for where the valence is, and write for me the correct compound of aluminium sulfate. This one is not aluminium sulfate, it is something else. Aluminium sulfate. Follow the steps here. Write the correct symbol of the element from the table, this table of ours that we have here. This table, aluminium is here. Come and pick a sulfate. It is there with the power. Allow the powers to exchange and write the compound the way it is. Don't change anything. Aluminium sulfate. Hey, where is the answer? Yes? Joshua? Joshua,
Yes, teacher.
where is the answer?
Teacher, I'm having a problem with my background.
Why?
There's a lot of noise.
Who is there?
There's a lot of people.
Ah. Elizabeth? Elizabeth?
Yes, teacher.
What is the formula you have?
Teacher, I'm still working out.
Okay, well, be fast, be fast. Rebecca? Rebecca?
Samia was disconnected.
The what? Yes?
I was on and off, on off.
So you have
I
not
was
under...
on and off.
Okay,
Yes.
we have noted that. Okay, let's go back to the steps we had up here. That when you are forming a compound,
One.
try to minimize noise. Elise, mute your microphone. Mute. So when you're writing the symbol or the compound, when you're forming a compound, this is what you should do. Number one, write the correct symbol of the element or radicals present. Two, the valence, since we said valence is the combining power of an element, it must be present. And then lastly, is to show how those powers exchange and give us the compound. An example, we looked at the formation of ammonium carbonate. Ammonium is here, is NH4. If you look at it from here, in the table, we have NH4 plus, it has valence 1, so it is NH4 plus. This is what we have written here, NH4 plus. Now, from here, ammonium carbonate, ammonium carbonate. Go to the table, just copy the formulas for now, but if a test comes, you will not copy, you must get them. So ammonium is NH4, the carbonate is CO3, like that. That is what we are saying at first. Write the correct symbol of the element or radical present. Now, after that, shift to 2. That says write the valence, the correct valency, because the valence is the combining power of that element. Look at ammonia where it is in this table. It is under valence 1. Just write 1 on top. 1 or plus 1. It still remains the same thing. 2, go to a carbonate. Where's the carbonate? It is here. It is under valence 2. On the radicals, it is in the valence 2. So go and copy. This one is negative 2. So when you are forming a compound, we see the power exchange. Ammonium 1, a carbonate 2 minus. So this one comes down here, while this one goes that side. There must be power exchange. This one comes this side, that one goes the other side. So we shall form NH4. It has 2. So the whole of this is under one category, that is 2. Then you write a carbonate CO3. Because it has 1, it just remains like that. So the whole formula becomes NH4. This is 2, CO3. That is the final compound called ammonium carbonate. Is that clear? Is that clear?
Yes.
So we have formed this. Then we went further to look at the second example, that had the magnesium sulfate. We looked at the second example that had magnesium sulfate. People are moving, people are running. Where are they going? Magnesium sulfate. we looked at magnesium. We write the correct symbol of magnesium as Mg. The sulfate on the table is here. It is SO4. Now go and copy the valences. Valence of magnesium is under 2, so it is 2 plus. Then the sulfate is here, 2 minus, so it becomes 2 minus. Now, since these powers are the same, they first reduce each other. Since they are the same, they reduce each other. This one becomes divide by 2 is 1, divide by 2 is 1. So you get magnesium 1 plus, then a sulfate SO4, 1 negative. So the formula becomes Mg SO4. This is magnesium sulfate. That is the second example. Now we wrote a question somewhere that they write for us aluminium sulfate. Aluminium sulfate. Following the procedures above, how do you start? Rebecca, how do you start? Huh? The first thing is to write the elements or radicals present. We have aluminium Al and the sulfate, which is SO4. That 4, if the 4 is not there, it is a wrong substance. It is SO4. Now go and look for the powers. What is the power of aluminium? The valence of aluminium is what?
3.
It is 3 plus. What is the valence of a sulfate?
-2.
-2. Thank you. Now, if you are writing the compound, what happens? What happens next? After writing this, what happens next? Ruth.
Exchange powers.
Ruth, what happens next? Elise. Elizabeth. Elizabeth, what happens next? The next step is to show power exchange. These powers only. So these 2 crosses to aluminium. The 3 goes to sulfate. So our compound becomes aluminium Al. Since we cannot reduce them, they just copy them like that. Al2 SO4, the valence is 3. That is a compound known as aluminium sulfate. This one. Any question? Yes? Rebecca. Joshua. Joshua. Can we unmute and talk, because I need questions from you now.
Teacher,
Yes.
please repeat. I was on and off.
This is Ruth.
Yes.
Okay. I'm going to repeat. Any question yet? Rebecca. Rebecca is quiet. Joshua.
Yes, teacher.
Now you have understood.
Teacher, the network was kind of freezing, but it was not going off, but it was, the screen was freezing. I don't know why.
Elizabeth, can I get a report from you? Elizabeth?
Yes, teacher.
Yes, I want a report from you. Have you understood?
Teacher, the school, she have not understood.
Rebecca? Rebecca?
Yes, teacher.
Any report?
Yes.
What is the report? Give me the report.
Teacher, they repeat.
The repeat of this work. Eh?
Yes.
Okay. Have you written these steps down? Hmm? Have you written them down? Yes?
Yes.
Good. So if you know how to write the correct symbol of the element, yes.
Teacher, which saying?
Huh? The steps are here. Steps for compound formation, they are here. Write the correct symbol of the element, stroke or radical present, get the valency, and then what follows is a power exchange. If the numbers cannot be reduced, the powers cannot be reduced. Or if they are not of there's a common factor, they don't have any common factor in them, just write the power exchange. If they have a common factor, reduce and then exchange the remaining powers. Hmm? Yes? So here they are saying, number one, you want like this substance, ammonium carbonate. Our first step says, correct symbol of the element or radical present. Which element is here? We have ammonium and the carbonate, isn't it?
Yes.
Now, ammonium on the table, if you go to our table here, it is written as NH4 plus, it has a valence 1. So we copy it and bring NH4, it has valence 1 plus. A carbonate is CO3. What is the power? Here in the table.
Two.
2. So it becomes 2 minus. Now these ones, you cannot reduce 2 and 1. They are the same things. So what you do, you write what? Ion exchange, isn't it? The power exchange. Now, these 2 will shift to ammonia. Then the 1 of ammonia will go to the carbonate. Is it clear?
Yes.
Yes?
Yes.
Okay. So finally, what you see is a power exchange here. This 2 is from this part, then the 1 is from this side. So the end product is what you write down as this. Is it understood now?
Yes.
The same happens to this. Why I brought this is because the powers cross out. Okay, like this one, they have the same factors. If you divide by 2, these ones reduce. So magnesium, you write, go to the table, check where it falls. Go to this other one also, check where it falls. So they all have 2, 2. In the end product, they reduce their powers and the product remains as that. Where are others? Joshua?
Yes.
Now you're picking. Yes?
Yes.
Good. So if they say aluminium sulfate, The first symbol for you to write is the one of aluminium, Al. And then you go to a sulfate, which is SO4. Go and look for their powers. Aluminium has 3 plus, the sulfate has 2 minus. So these ones cannot be reduced. So what you do the power exchange. Now, if you change the power and maybe put 3 in between this, that is wrong. The 3 is a power now for all this word SO4. That's where the 3 comes. So the 3 comes here, then the 2 goes there. That's why you find aluminium has 2, SO4 has 3 here. The compound is called aluminium sulfate. Have we understood?
Yes.
Okay. These people have escaped, but the video will find them there. Rebecca? Rebecca?
Yes.
Have you got it? Hmm? Yes? Now, if you have got it, I want this substance here. Lead nitrate. Lead nitrate, a compound called lead nitrate. How does it look like? I'm giving you about 2 minutes to write that. 2 minutes. So this paper has exercise on it. This paper here you are seeing. So I'm going to send you all these compounds here. You are going to write most of them and you give me the feedback of what has happened. Is it clear?
Yes.
Good. So I want the one of lead nitrate. 2 minutes. Yes, Ruth. What is the answer? She has
Yeah,
gone.
still right.
She's there. The answer is
No, I'm still writing.
you are still
I'm
writing.
still writing.
Time
Yes.
is going. The 2 minutes have gone. Write very fast. Go to the table, find the lead. Lead is PB. Nitrate is NO3. Look for the valency and make sure they exchange very fast. This is the start, but when you get whatever, you will be writing these things in 2 seconds.
Yes.
Lead is there, lead to ions, the valence is there, the nitrate is here, NO3, the under valence 1. So right. Mm-hmm. So where you are, there is some work here. Take a screenshot of it, ABC, and then try to make sure that you come up with these compounds. Okay?
Yes.
Take a screenshot, and if you are stuck, here we go. This is what you use. That is the number you use. You WhatsApp me on that number. I give you ideas of how to go about. Okay?
Yes.
Okay.
Teacher,
Mm.
teacher,
Mm-hmm.
can you put this table like the compound table in the homework?
Yeah, I'm going to put it there.
Okay.
I'm going to put it there. So who has the answer?
I tried.
Yes.
It's PB
Mm-hmm.
and NO2.
NO, there is a
2.
3. Where have you put the 3?
Okay.
There's a 3
Which I
inside.
try.
Yes.
PB3
PB3,
NO2
PB3,
NO2.
NO2.
Hey.
No. Never remove what is inside. Because this is one compound. We looked at radicals, how they come about. This never remove what is inside here. The powers just come straight outside the bracket. Is it clear?
Yes.
Okay. That 3 does not come out. It is actually the 2 up here that is supposed to cross the page, the border, and goes down there.
PB.
So it becomes what?
PBNO3.
They are brackets. They are brackets on NO3. Make sure you use these brackets properly.
Yes.
Mm-hmm.